Ryzev, and today we're going to be talking about reflections.
So first things first, what is a reflection? Well, a reflection is basically a flip. Now, you can describe a reflection and say its characteristics are that it preserves the distance of a figure, its angle measure, and also the betweenness of points. We know that a reflection is a type of transformation. Transformations include dilations and also reflections. It is known as a congruence transformation because it is the same size and the same shape after it's reflected. There are a couple of other terms when dealing with reflections, such as congruence transformation, which I described previously. Also, line of reflection. This is the line which you reflect a figure across. There also is image and the pre-image. An image is the original figure, and then the pre-image is its prime. So also, the line of reflection is also known as a perpendicular bisector because the distance between the 2 points, the original and the prime, are equal, making the line of reflection a bisector. There's also something known as an invariant point, which you will see an example of later on in the video. If you're taking notes, it would be a good time to label the x-axis, y-axis, and the line y equals x. These will be important. So for the concept of reflecting a line across the line y equals x, you are going to take your coordinates x and y, and you're going to flip them. Your coordinates will now be y and x. To reflect over the y-axis, you're going to make your x variable negative. So if your variable is already a negative, you would make it a positive. And if it's a positive, you would make it a negative. Now for reflecting across the x-axis, you're going to do the same thing but to y. If y is already negative, make it a positive. If y is already positive, make it a negative. It's really quite simple, and you'll see that in our next problem. So this problem, we're going to reflect triangle ABC across the x-axis. I've already took the time to draw the figure, label it, and its points. Now I'm going to draw a prime, C prime, and B prime. As you can see, it is reflected across the x-axis, and the only thing that I did change was make on A, point A, 3 negative, and here we have an invariant point. Why didn't I change 0 to make it negative or times it by -1? Well, it lies on the line of reflection, and any point that lies on the line of reflection maps onto itself. So that's basically what an invariant point is. Now we'll reflect across the y-axis, and remember the rule is change only the x variable. If it's a positive, make it a negative. If it's a negative, make it a positive. So our figure is figure DEFG. We have our points, and we're just going to connect them. If you look at the points, point D is -2, +3. E is +5, +3, and the rest are positive. But when you reflect them, the points of point D go from a -2 to a +2, and the +5 turns into a -5, but only the x variables change. Moving on to the line y equals x. It's a very interesting line, and we'll be reflecting the figure HIJKL. Now this has 5 points, just to give you a range of different types of problems that you may see. When reflecting across the line y equals x, remember to flip your variables. So for instance, you can see that h is 1, 3. Well, if you had to reflect it across the line y equals x, what do you think its points would be? What would h prime be? Well, first things first, I would graph my original figure, label it HIJKL, as you can see, and then draw an arrow, maybe in a different color or a different type of pen. Don't use pen, this is math. As you can see, H prime is 3, 1, and H, the original H, is 1, 3. Now all that's left to do is to draw this image. You already have the pre-image, and now you will draw HIJKL's image. And also label this image and make sure to use your prime so that you can see which figure is the image and which figure is the pre-image if you don't have another color pencil.